Hello students, this is my video lecture number 2 and our today's topic is effects of refraction of light. Now the first effect of refraction of light is that a stick partly immersed in water appears to be bent at water's surface. So here we have a stick that is partly immersed in water and held obliquely, so this straight stick appears to be bent to us. This apparent bending is caused by refraction of light when light passes from water into air. So AO is that stick and this stick is held obliquely and partly immersed in water. So this straight stick appears to be bent in direction BI at point B. Now why is this happening? So to understand this concept, let us take the lower end of the stick AO, that is portion O. Now light ray OC passes from water into air, so its refraction will take place. So it will be refracted in direction CX. Similarly, there is another light ray OD which is passing from water into air, so it also gets refracted in direction dy. If these two refracted rays are produced backwards, they appear to meet at point I. So I is the virtual image of the lower end of stick AO, that is of the O. Now I is closer to the surface of water in comparison to O. Now we have only considered the lower end of the stick, but the portion B of the stick is made up of so many points. So if we apply same concept to each and every portion of the stick BO, then we will get BI as the virtual image of portion BO. BI is the virtual image of portion BO, and AB and BI, they are not on the same straight line. That is why stick appears to be bent to us. Instead of using a stick, we can also use a pencil. Now the second effect of refraction of light is that an object placed under water appears to be raised. So to understand this concept, let us take a look at these diagrams. So here we have a beaker. This beaker is empty and at the bottom of this beaker we have placed a coin. OA and OB are two straight rays of light. Now we have to move our head away from the beaker till this coin disappears. That is, we are not able to see it. Now without changing the position of our head, we have to pour some water into this beaker. So the coin which was initially invisible to us suddenly becomes visible. That is, we are able to see it. And it appears to be raised to us. Now let's see how is this happening. Now light ray OA passes from water into air. So it gets refracted in direction AX. Similarly, another light ray OB passes from water into air, so it gets refracted in direction BY. So if AX and BY are produced backwards, they appear to meet at point I. So I is the virtual image of O. Now I is closer to the surface of water in comparison to O. That is why an object placed under water appears to be raised. Now third effect of refraction of light is that a pool of water appears less deep than it actually is. So here we have a pool and this pool is filled with water. Now we have taken a point at the bottom of the pool and that point is point 2. From this point, a light ray OA passes from water into air, so it gets refracted in direction AX. Similarly, there is another light ray OB which passes from water into air, so it gets refracted in direction BY. Now if these refracted rays, that is AX and BY, are produced backwards, they appear to meet at point I. Now I is the virtual image of point O. Here we have considered only one point, point O. But the bottom of the pool is made up of so many points. So if we apply same principle to each and every point at the bottom of the pool, we are going to get the virtual image of bottom along the line P dash Q dash. This dark dotted line is the virtual image of bottom. So this virtual image of bottom is closer to the surface of water. So this is our apparent depth. This is our real depth. Since P dash Q dash is closer to the surface of water, so a pool of water appears less deep than it actually is. Now our next topic is laws of refraction of light. So first law of refraction of light is that the incident ray, the refracted ray and normal at the point of incidence, they all lie in same plane. So here light is passing from one medium into another medium. So this is our incident ray, this is our refracted ray. As light ray changes its medium, its direction also changes. It bends. This is angle of incidence, which is measured with respect to normal. This is angle of refraction. Now, according to first law, this incident ray, refracted ray, and normal, they all lie in same plane. So if you consider this page to be a plane, so they will remain in the plane of the page. Now the second law. This law gives us relationship between angle of incidence and angle of refraction. This relationship was discovered by a scientist named Snell. This law is also known as Snell's law of refraction, or simply Snell's law. According to Snell's law, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. Given pair of media means, suppose light is passing from air into glass. So air and glass forms a pair of media. And if light is passing from air into water, then air and water forms a pair of media. Media is plural for medium. Now, according to Snell's law, sin I and upon sin R is a constant value. And this constant value is known as refractive index. This refractive index is denoted by small n. So, according to Snell's law, small n, that is refractive index, is equal to sin I upon sin R. Now, since refractive index is the ratio of two similar quantities here, sine and sine, these are two similar quantities, so it has no units. So, refractive index is unitless. So, basically, refractive index gives us indication of the light bending ability of that medium. Greater is the refractive index of the medium, greater is the bending of light. As we all know, refractive index of glass is greater than the refractive index of water. So when light passes from air into glass, it bends more in comparison to when it passes from air into water. Now, what does refractive index of glass actually mean? It simply means that we have to calculate value of sin I upon sin R when light passes from air into glass. For example, here, suppose this is air and this is glass. Now light is passing from air into glass. If you know the value of I and R, you simply calculate sin I upon sin R, and this sin I upon sin R ratio is nothing but our refractive index. Now here is a numerical for you. A beam of light passes from air into a substance X. If the angle of incidence is 72 degrees and angle of refraction to be 40 degrees, calculate refractive index of the substance X. Now refractive index and speed of light. So far we have calculated the value of refractive index in terms of angle of incidence and angle of refraction. That is, if you know the value of angle of incidence and the value of angle of refraction, you can easily calculate refractive index by taking sin I upon sin R. Now here we will try to find the value of refractive index in terms of speed of light. So here is the situation. This is medium 1, this is medium 2. Now light passes from medium 1 to medium 2. Speed of light in medium 1 is v1, speed of light in medium 2 is v2. I is the angle of incidence, that is the angle between normal and incident ray. R is the angle of refraction, that is angle between refracted ray and normal. Now, since light is first coming into medium 1 and then into medium 2, so we will calculate refractive index of medium 2 with respect to medium 1. जिस मीडियम में लाइट रे बाद में जाती है उसका रिफ्रैक्टिव इंडेक्स निकलता है उस मीडियम की रिस्पेक्ट में जिसमें लाइट रे पहले आई. सो how this statement is written, that is refractive index of medium 2 with respect to medium 1 is written like this, small n, that is refractive index of medium 2. जिसमें बाद में आई लाइट रे उसको बाद में लिखेंगे या फिर कह सकते हैं राइट में लिखेंगे. विद रिस्पेक्ट टू मीडियम 1, तो जिस मीडियम में लाइट रे पहले आई थी उसको लेफ्ट में लिखेंगे या पहले लिखेंगे, और वो किसके इक्वल टू होगा, स्पीड ऑफ लाइट इन मीडियम 1 अपॉन मीडियम 2. यानी कि जिस मीडियम में लाइट पहले आई उस मीडियम में क्या स्पीड थी डिवाइडेड बाय जिस मीडियम में लाइट बाद में आई उस मीडियम में क्या स्पीड है. सो वी कैन सिंपली राइट इट n21, that is refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1 upon speed of light in medium 2. Now So far we have considered the situation when light passes from air into glass or air into water. Here we have a situation where light is passing from water into glass. So when light goes from one medium to another medium, the value of refractive index is called as relative refractive index. If light passes from air into another medium, then refractive index is known as absolute refractive index. But if light passes from one medium to another medium and both of these media are different from air, then refractive index is known as relative refractive index. So this is your relative refractive index. So refractive index of glass with respect to water is speed of light in medium 1, that is v1, upon speed of light in medium 2, that is v2. तो जिस मीडियम में लाइट रे बाद में आई, तो ग्लास में बाद में आई, तो उसका रिफ्रैक्टिव इंडेक्स निकाला किसकी रिस्पेक्ट में, जिसमें लाइट रे पहले एंटर थी, दैट इज वाटर. सो रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू वाटर इज v1, यानी जिस मीडियम में पहले लाइट रे एंटर की थी उसमें क्या स्पीड थी, v1 थी, और बाद में जिस मीडियम में लाइट रे आती है उस मीडियम में लाइट रे की क्या स्पीड है, v2. सो v1 by v2. So refractive index of glass with respect to water is nothing but refractive index of glass when light passes from water into air. Sorry, water into glass. Now, when light enters from vacuum or air, vacuum and air are one and same thing. Speed of light in vacuum and air is almost same. So, when light enters from vacuum or air to another medium, then value of refractive index is called absolute refractive index. So here, light is passing from air into glass. तो बाद में किस मीडियम में आई, ग्लास में. सो रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू एयर और वाटर इज इक्वल टू स्पीड ऑफ लाइट इन मीडियम 1 अपॉन स्पीड ऑफ light in medium 2. So it is not necessary to write air or vacuum, you can simply write ng. So ng means refractive index of glass, this is equal to speed of light in air upon speed of light in glass. Now this is another numerical. Light enters from air into glass plate having refractive index 1.50. What is the speed of light in glass? So you have to solve this numerical by yourself. Now refractive index for refractive index for light going from medium 1 to medium 2 is equal to the reciprocal of refractive index for light going from medium 2 to medium 1. So here we have a situation. In first diagram, light is coming from medium 1 to medium 2. In second case, light is going from medium 2 to medium 1. So in medium 1, speed of light is v1. In medium 2, speed of light is v2. This is medium 1, this is medium 2, this is incident ray, this is refractive ray. तो बाद में किस मीडियम में आ रही है, मीडियम 2 में. सो रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 2 किससे होते हुए है, मीडियम 1. सो रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 2 विद रिस्पेक्ट टू मीडियम 1 इज इक्वल टू पहले किस मीडियम में आई थी, उस मीडियम में क्या स्पीड थी, v1, डिवाइड बाय दूसरी बार जिस मीडियम में एंटर करती है उसमें क्या स्पीड है, v2. सो v1 बाय v2. सिमिलरली यहाँ से पहले किस मीडियम में, मीडियम 2 में. सो किसका रिफ्रैक्टिव इंडेक्स निकलेगा, मीडियम 1 का, जिसमें बाद में. सो रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 1 विद रिस्पेक्ट टू मीडियम 2 इज इक्वल टू पहले किस मीडियम में जा रही है, v2, डिवाइडेड बाय दूसरी बार जिस मीडियम में एंटर करती है उस मीडियम में क्या स्पीड है लाइट की, v1. सो रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 1 with respect to medium 2 is v2 by v1. If we multiply these equations, we get this equation. Now refractive index of medium 2 with respect to medium 1 is reciprocal of refractive index of medium 1 with respect to medium 2. So if you know the refractive index of one medium with respect to another medium, and if you take its reciprocal, then you get the value of refractive index in the other sense. That is, suppose medium 1 is air and medium 2 is glass. So refractive index of glass with respect to air is simply the inverse of refractive index of air with respect to glass. So if refractive index of air with respect to glass is given to you and you take its inverse, so you will get value of refractive index of glass with respect to air. Now here we have 3 more questions that you have to solve. Thank you.